All right, so in this next video, we're going to just take a look at some of the practical application of this whole concavity thing. So we're going to start with this example that's on the next page of your packet. It says to consider the following graphs of the population as a function of time. And then down here, we're supposed to describe which is which. So for graph A, P is we're supposed to be describing, we can describe both the concavity and the whether it's increasing or decreasing. So P is increasing and concave up. Okay, and the rate of change of P, okay, so if we think about the rate of change, that's kind of like the slopes. So I'm going to give you a good visual here. Hopefully this will help a little bit. So if I look at slopes between points that are kind of close together, so say the slope between these 2 points, for instance, okay, so there's one slope, the next slope goes from there to there, next slope goes from there to there, and there to there. All right, you can kind of see these slopes are getting a little bit steeper over time. So that would suggest that the slopes are increasing, and that means the rate of change of P is increasing. Okay, for letter B, we have a function that's going up over time. So that would be an increasing function. So I'm just going to make that abbreviated. So it's increasing and concave. And now look back at that picture. That one's concave down. All right, so that one's increasing and concave down. Now the rate of change, again, we want to look at what's happening to the slopes over time. So starting here, we could get a slope that's kind of right along with it. My next slope is a little bit shallower. Okay, it's kind of hard to tell right here, but as we get a little bit further along, we can start to see the slopes are going to get shallower over time. All right, so it was steep at first and it's getting shallower, so that would be suggesting that the slopes are decreasing, or the rate of change is decreasing.
Are you coming up soon? Just wanted to know.
P in graph C is, and I'm going to have you kind of take a little pause here and guess on the last two what they are. I think you can figure it out. Okay, so the last two, you should have P is decreasing and concave down, and the rate of change of P is decreasing. Okay, the last one is decreasing and concave up, and the rate of change of P is increasing. Now, what's interesting here, this is the thing that's difficult for people to understand, is that when I say increasing here, it doesn't really look like it's increasing, and we're going to go back to the other one and see the decreasing part as well. This one doesn't really look like decreasing as far as the rate of change right away. This might seem a little bit more obvious, but again, if we look at our rate of change, it's a shallow negative rate of change, a less shallow, so a steeper negative, and then a steeper negative, and then a steeper negative. And so what we're going to see here is, if I were to use examples, it'd be like maybe this slope is -1/2, and maybe this is -1, and this is -2, and this is -3. So if you look at those numbers over time, it's actually decreasing in value. -1/2 to -1. -1 is smaller in value, and that's kind of continuing the pattern for all those. This one is the least obvious, um, and as far as like what's going on with the slopes, but I'm going to try and show it to you. So again, we start here. We have a slope that's negative, and we'd say relatively large negative. So let's call this -3 for right now. Okay. This one doesn't look a whole lot different, so that's maybe like -2.5, but it is a little bit shallower. This one is, again, a little bit shallower than that previous one, so maybe -2. This one, a little bit shallower than that, -1.5 maybe, and so on. Okay, I think you're getting the idea. So what's happening here is I'm going from -3 to -1. That is technically getting bigger in value, so it's increasing. So because it's increasing rate of change, it's going to be a concave up function. All right, so to add to this, I think this is really important for us to say. All right, so for concave up has increasing average rates of change. Okay, so there's that. And then let's take this thing. Oh, does that not work? Boo. All right, and then similarly here, concave down as decreasing average rates of change. Okay, that'll help you kind of distinguish the two, especially as we're looking at a table. So we're going to get even more specific in the next video. We're going to apply this to some examples and exercises, so just stick with me on that one.